Namaskar, welcome back. In last lecture, we discussed about the significance of historical and modern seismicity, and we took the example of Himalayas, where we were talking about that how the historical earthquakes uh, were been plotted on the map, and plus the intensity maps were been prepared based on the rupture areas and all that. Uh, Of course, the exact intensity map I did not show, but yes, in coming slides probably will be able to see, or maybe in the next lecture we will discuss about that when we are talking about the seismicity and seismic waves particularly. Now we also tried. We did one exercise for Kutch where we had, of course, the big earthquakes, large earthquakes. One was in 1819 and another 1956. That was moderate magnitude earthquake, and then we had a recent 2001. So we tried with the information which was available from Gazetteer, because every state has a Gazetteer which is available in the museum or maybe in the library, district library or the state library. So you can use that. In that all descriptions are been given. Of course, the that also the information which was present in the Gazetteer was from the historical database. So we tried that, and then the descriptions which were been given for the earthquake, we wanted to understand that what could be the size of the earthquake in terms of the magnitude. So earlier, uh, uh, like in 90s, or we can say that, or maybe before that also, the terms usually were been used: the small, moderate, large, and great earthquakes. Okay, now that can be related to your the magnitudes range also. So small means less than, we can say, if 6 magnitude, so around 5.5 magnitude, we will say the small magnitude earthquake. Moderate magnitude earthquake, we will range around less than equal to 6, or less than 7 magnitude. Large magnitude will be definitely greater than 7 or equal to 7 magnitude, and you can go up to 7.5 or so. But great, again, now the nomenclature again has been revised, and we started using that if the great earthquakes are there, then we say it is greater than 8 or 8 point, around 8.5. Similarly, in some literature, as I was mentioning that in Gazetteer and all that, we found that there are words or the phrases which were been used like slide, fed slightly. Now this is based on uh, the the observer who is getting or felt this earthquake, or he or she, or whatever the observer, he how he describes or she describes the earthquake felt. Okay, felt slightly, uh, sharp, strongly felt, and then so this phrases were available, and few, if they are large magnitude earthquake, definitely it will result into the damage and all that. Now similar description is also been used uh, in your intensity, the seismic intensity, if you want to talk about. Okay, which we will definitely discuss when we are talking about the intensity and magnitude. What is the difference between the intensity of magnitude? So these were the phrases. Now, with this phrases or the words which were been described in Gazetted, we tried to match with the intensity. However, there is a relation which was available. So this paper, which was published in Journal of Geological Society, India, and we collected all the information which was available as in this abstract I have mentioned somewhere, that the earthquakes which were listed in the historical and now instrumental data. So earthquake which were listed in the Gazetteer. Okay, so this we considered, and based on the keywords which were been shown, okay, like slide, very slight, severe, very severe, okay, strong, were frequently found in the description. Now, this words which were available were been converted into the modified Markali scale, and for that we can assign them the local magnitude. So there is a relation which has been given by Gutenberg and Richter, which was given in 1956. Okay, so this is the equation you are having, and this is what you will have the sort of an intensity. Okay, so based on the words which were been used or the phrases, we converted that into intensity, and the intensity were been used to calculate the magnitude. Okay, and then what we did, irrespective of the like how many numbers of information we got, we tried to plot this on the structural map. Okay, structural map is geological structural map we are talking about, where we have the fault lines and demarcated by the geologist. Okay, these are not really in the active fault, but of course the active faults are close to this only. But this lines which you see here, the light blue lines, are all fault lines. Okay, where we say the Kutch Mainland fault, Katrol Hill fault, then there you are having the Allaband fault. So this map was available, and then we plotted. Other than that, what we did was that we also looked at some organizations which are cataloging this type of earthquakes from the historical data and the modern seismicity which is going on. So we also collected that, and then we plotted. Okay, so seismicity of Kutch in last, so this was way back, because this we did in 19 uh, after 1995. Then the paper was published in 1998 or 99, if I'm not wrong. So this period till then, what we did, all earthquakes we tried to use from and collected and catalog from different sources. Okay, so first one was that IMD, Indian Meteorological Department. Okay, and then we used the Gazetteer of Kutch, which was published in 1971. Okay, and then the USGS, the catalog we used, which we will you usually you find that they have all historical data also fed cataloged in their website. Okay. And now we are having the our own like agency which is under the umbrella of Ministry of Earth, and that is National Seismological Center at New Delhi. So you can have the data from there also. Okay, then there were some papers which were available, research papers. We also took into consideration that. Okay, which was published in 1979. Now with this, uh, to some extent, we tried to uh, uh, correct, not exactly correct, but we will say that if there is some sort of an confusion, or maybe the data is not reliable, something, we deleted those, but we tried to plot. Okay, now when we plotted this earthquakes, then we saw that there is some sort of an alignment or the orientation, we can say, these earthquakes are having along the fault zones. Okay, so one, if you see this one carefully, there is some sort of an pattern which has been seen here. Okay, and this fault, that is Katrol Hill fault, was responsible probably in triggering 1956 earthquake of Anjar. Magnitude here it is given 7, in because in some literature it talks about 7, but it was not 7, it was 6.5 or so. So there is one clear cut pattern which we see here along the Katrol Hill fault. Then what we found, that this is the area which is the part of South Wagad Island. We have some pattern here, and then we see as some earthquakes which have triggered along this year Kutch mainland fault. Okay, and there was a gap here actually. We did not see any earthquake. Okay, I'm not very a much I don't know whether how far this is true, but if I just try to look at this area, that you have this part here, this earthquakes, which are of course not very large earthquakes, having the magnitude ranging from 3 or less than 5. Okay, but there is some sort of an gap which we did not see in much like number of earthquakes we were not able to see, and this was the area which had like your 2001 earthquake. So I don't know whether if that has been reflected here, but again the question remains that this less than 5 magnitude will not suffice the energy of 7 magnitude earthquake. You need thousands of earthquakes to be. Another thing what we observed was that this earthquake, which was not exactly here, the epicenters were not precisely given. Okay, because this was triggered on the 11th fault or by the 11th fault. But there are this earthquake we see here, and plus if you see which is like 5 to 9 magnitude. Okay, 9 magnitude. This area can't produce that large magnitude earthquake. It doesn't have that much of potential. But yes, it can produce up to 7.5 or 7.8 magnitude earthquakes. Okay, so there are many earthquakes which have been listed here, but this was so far I remember that they were all been felt by the people and they reported. So it was more or less this was the same earthquake of 1819, okay, which was been felt. But nevertheless, this also gave us an idea that how the seismicity pattern looks like in this area. Okay. So we will also discuss when we are talking about the Kutch part in particular. We will discuss about that. Now, the one part which we discussed was the historical data, and then the historical data like the occurrence of the earthquake which is available. This is also another important aspect which is very well taken up in Europe. That is what we call the signatures you see from the archaeological site. Okay, because the ancient earthquakes probably or must have affected this settlements. Okay. So whether we see any such signatures which are preserved, which affected, which got the sites which got affected because of strong ground shaking during major earthquakes, and whether such sites are available in the vulnerable zones which we are having in India. So answer is yes for that. So we have Kutch, we have Indo-Gangetic plains where the huge ancient settlement was there, and of course in Kutch we had the your Indus Valley civilization, Harappans, and then later on also there are a lot of historical sites. And in the Indo-Gangetic plain we have lot many sites which can be studied, and if they were damaged. Okay, of course they must have been affected during the large magnitude earthquake during the historical times. Okay, so uh, this branch uh, helped in also understanding that what could have been the what would was the seismic intensity by a particular earthquake. So signatures of ancient earthquakes from archaeological sites and structures which are then. Okay. So this can also help us in understanding that and sort of in predicting that what could be the intensity one can experience at that particular or in that particular area from major earthquakes triggered from in the seismic zones, okay, like Himalaya, and then you are having Kutch and in Andaman Nicobar for India. Okay. Now, and then in like a couple of institutes they came together and they started working on this. In India, this was initiated in 2012. there was like we wanted to have a safety and conservation for heritage structures. Okay, so this was again after the 2011 Sikkim earthquake, and this workshop was been organized um, collectively by Indian Institute of Technology Madras and then Archaeological Survey of India. So, and basically we were talking about that how to uh, conserve and provide safeties to the ancient structures. Okay, but at the same time, we also felt that why can't we use this information if it is available in the archaeological structures, okay, or the ancient structures. So this slide, if you see, I will be like showing a couple of slides which I borrowed from one of my good friend, Professor McRoy from Strasbourg, France. So his team is working on this type of, and they have multiple collective small projects which are working in different areas in Europe, and this project is been supported by European Commission. So it says Archaeoseismology for protection of cultural heritage and archaeological sites in Middle East. Okay, of course this is in Middle East, but it also talks about that in the European side. And the project name was APAME. So similar exercise was also initiated, as I mentioned about at IIT Madras, which was again in collective efforts from IIT Kanpur was also involved in this. So we have a very strong group working on the structural engineering part. Okay, so a couple of slides from this project APAME. So what they did, they studied, of course, many other sites also. I have few slides from Italy also, where you will see the Roman temples got affected because of faults and all that. So this story comes from Syria, Dead Sea Fault, okay, which we also discussed briefly during the plate tectonics part. Okay, so this like slides or the presentation is from Professor McRoy and his team. Okay, so this is from the project is known as APAME. Now, again, that's the story part comes here, that where exactly this area falls. It is over here. Okay, so the Dead Sea Fault goes somewhere like this. Okay, this one. So this is again between the because of the transform fault, where you have so this is what we are having, and this is you have that is between the because of the movement of the Arabian plate, and then you are having the African plate rifting. Okay, so this gives rise to your fault, which is lift lateral fault. Okay, so because if you look at here, this one, then this portion is going like this. Okay, and this portion is moving like that. Okay, so you can see this area also, which clearly marks the short of one boundary. Okay, so this is for the Dead Sea Fault. Now what they did was that they looked at some the past and the present, like historical and modern seismicity, and they found that the Dead Sea Fault is quite active and has a potential to trigger large magnitude earthquake. So whether that happened in the past, okay, can we like talk about that what safety must be taken in the future for in this area and the nearby region. Okay, so they tried to look at the satellite data and all that, and that what we are going to study over here. But briefly, let us let us discuss in brief here what we this Al Harif Equadat, they selected one side and they did very detailed study here. So of course, the first step will be about our satellite data interpretations and all that. So they found very clear and sharp uh, uh, like fault trace, which have been marked by this one here. Okay, and this is the location of Al Harif. Okay. So this again they were able to see a very clear displacement of the aqueduct. Okay, so this is what they call the Arabian plate side, and this side you are having the Arabian plate, African and Arabian plate side. Okay, and where the fault zone is at, is like displacing both the walls. Okay, so this is what the displacement here. The total displacement which was been observed uh, in this the displacement total displacement of the aqueduct was around 13.6 meter, and that was not uh, in one go. Okay, so they did very detailed studies. Actually, they even did with lidar and all that. Okay, and they also found some inscription which dated back to like 1600 to 1100 BC. Okay, and further they also, like you can see on the fault trace the digital elevation model which shows the fault displacement. Okay, so this part has been moving this way, this part is going up. Okay, and then slowly they also based on the carbon dating and the OSL they did not do, mostly the carbon dating. They reconstructed this, that what how many events could have occurred to finally give this here it is written 13.6 meter of total displacement. So that what I was talking about, that it was not in one go, that was not here. Okay, they were unable to trace what is the amount here, but this one they were able to talk about that this is 4.3 meters of displacement. Okay, and they were able to identify that there were like multiple events, not only so this is what we see, the 13.6 is your cumulative displacement. Okay, this 13.6 is the cumulative displacement, not in the single go. Okay, so multiple earthquakes resulted into that. So there was an earthquake. So before this, probably this aqueduct was been built in 13 to 770 AD, and there was probably an earthquake which was not well constrained, so they put a question mark in 115 AD. Then there was another one around 700 to 100 and like 1030, and then finally they had an earthquake of 1170 AD. So there was like multiple events probably occurred in this area. Okay, and they were able to identify the clear cut displacement of the aqueduct, prepared very detailed map, and then they also opened up the trenches across the fault to understand of course they got the ages from this trench only, and they were able to reconstruct this. So you see a clear cut like deformation of the aqueduct over here, and then we will able to see the displacement, total displacement. Okay, so such things can help us in identifying the ancient earthquakes which affected the got affected because of the major earthquakes. Okay, so this is the same area, the fault zone which you see here. Okay, so this is the part slowly we will start learning. Okay, and now if the events which they identified, okay, we accept that, and let us say if we accept that and we consider that, fine, that probably were the events which have occurred in the past. Okay, you can also predict the future earthquake. Okay, so if you take this simple way of plotting this earthquake with respect to your cumulative left lateral slip, okay, that is amount of slip, and then you have the time here. Okay, so the first earthquake is slept here in 800, like 87 years back, and then another one was around 423. Third one was in around 832 years. So then with the best fit line you can talk about, you can predict the future one. Okay, so it could be somewhere over here. So you can have an earthquake, you can predict an earthquake here. Okay, so this is one of the good study which usually we come across. We'll talk about the Indian side. Okay, what we found in the Indian side and how we looked at those evidence and the signatures. We'll discuss in the next lecture. Till then, goodbye. Namaskar.